If matter is just knotted up space-time, then where in the world did the forces come from? And this is where the model gets incredibly powerful. The forces stop being these mysterious fields or exchanged particles and instead become simple, direct consequences of geometry. Let's start with the one we all know, gravity. To understand it in this new way, we have to do another one of those mental resets. Forget the idea of gravity as some mysterious force that's pulling things together. Instead, I want you to think of it as the natural tendency of the space-time fabric to smooth itself out. So, in this picture, a massive object, one of these dense knots of space-time, is kind of like a dent in a mattress. The space around it just naturally wants to, well, relax. It wants to flow back in and smooth out that dent. And that inward flow, that relaxation pressure, that's what we experience as gravity. So it's not a fundamental pull, it's an emergent push. So what about electromagnetism? Where does something like electric charge come from? It's just so elegant. Charge is simply the direction of the twist in the space-time knot. That's it. Is it spinning clockwise or counterclockwise? That one property is the origin of positive and negative charge. And this slide just makes it so incredibly clear. A knot with a clockwise twist, it behaves as a positive charge. One with a counterclockwise twist, it behaves as a negative charge. It just completely transforms this abstract property we call charge into a physical geometric feature you can actually visualize. And get this explains the electromagnetic force perfectly. Two knots that have opposite twists can mesh together, kind of like gears locking into place. That's attraction. But two knots with the same twist, they're going to clash and push each other away. That's repulsion. You don't need any mysterious force-carrying particles. It's just pure geometry in action. Okay, so what about the forces inside the atom?